So this lesson is on acceleration. Learning target for this lesson is I know how acceleration is measured and I can make calculations of acceleration. This video is going to focus mostly on knowing how acceleration is measured and knowing some of the concepts of acceleration. And the next video will focus mostly on the calculations of acceleration. If we have both of these vehicles, we have a race car and a dump truck, they could both be driving down the interstate at the same exact speed at 60 miles an hour. Right? There's not a difference between them when they're moving at that speed, obviously outside of the weight that they carry. But as soon as we saw them try to make a change in their speed, then we would notice a big difference between them. Same thing if you were sitting at a stoplight. If you had both of these two, sitting at a stoplight and they start revving their engines and they're looking over at each other and they're getting ready for a race, and all of a sudden they both just gas it when the light turns green, you know there's going to be a big difference between them. And so that change in velocity is what we're really looking at with these two vehicles, the difference between them. So let's say we had this situation. Both of these two cars are traveling down the road, maybe at 25 meters per second, and a smart car pulls out in front of them. So let's say that this dash line is 25 meters. And let's say that roughly about the same is about, let's say that dash line is about 50 meters. And let's say the cars are sitting at roughly 75 meters. Just so we have some numbers to work with here. So both of these two are driving down the road at 25 meters per second. So let's say in the first second, both of them make it to this 25 meter mark in 1 second. And I'll put a little X there showing that's 1 second. That's where they got to. And now all of a sudden they see this smart car pop out in front of them. And so they both start to hit the brakes. The race car here, let's say it travels maybe here in the next second. So this is at 2 seconds. And let's say the dump truck hits the brakes, but we know from experience that the dump truck is not going to slow down as fast as the race car. So it's probably going to travel, maybe it goes about here. It's probably not going to see a whole lot of change in that first second of hitting the brakes. So at 2 seconds it's there. Now, let's say the race car is still hitting the brakes. And in the third second, let's say it travels just a little bit less than it did the first time to right here. 3 seconds. And then, so the dump truck is still hitting the brakes, and it travels in its next second a little bit shorter than it did from seconds 1 to 2. So this is 3 seconds. By 4 seconds, this car stopped. Let's say hit the brakes right there. And the dump truck does not quite make it. By 4 seconds, it barely hits the tip of the smart car, and by second 5 it crashes in. Smart car is no more. Doesn't quite make it. Now, at the start, right here, both of these two cars were traveling at the same speed. They made it the same distance in the first second, but once they hit the brakes, their velocity changed. Right? The race car traveled less distance per second every time that brake was being applied, and the dump truck traveled more distance per second after that brake was applied. It slowed down much slower. And so this is a measure of the acceleration of those two. They were the same velocity at the start, but they had a different acceleration once they hit the brakes. And this is the measure of change in velocity during a period of time. So it's really looking at how much did the distance that they were traveling each second change during that time. And remember that from our velocity, the velocity can be a couple of different things. The things that make up velocity, the factors that make up velocity, is speed and direction. So if we change either one of these factors, we're going to be changing the velocity. And so there's a couple different ways that we can show this. We can show a car starts off slowly, brakes there, travels a little bit farther, and each one of these dashes is representing 1 second. So you can see that as time goes on, this car is traveling more distance in each second. In this first little part here, it didn't travel very far, but in this last part, it's traveling a lot of distance in that same amount of time, right? So its velocity is increasing. This would be an accelerating object. We could also draw the inverse of this. We could draw something like those two cars that we showed with the race car and the dump truck, something that is slowing down over time. It's covering less distance per second. Oops, right here, and then there. And so this is traveling a great deal of distance in 1 second at the start, and by the end it's barely traveling any distance in that same second. So this thing is still accelerating, but you know the way that we would say it is decelerating, but it has a negative acceleration, slowing down. So that's the speed changing of these objects, but we can also have an object that maybe starts right here, is traveling, and then in the next second maybe it turns. And it might be traveling the same distance in that second, which I'm kind of trying to draw, but it's changing its direction, and because its direction is changing, its velocity is changing, and since its velocity is changing, then it's accelerating. So really something that travels in a circle comes right back to where it started with, but it was accelerating the entire time. It could be traveling the same speed around that circle, but because it was changing directions, it was accelerating. So accelerating is a change in speed and direction. And if we were going to take a look at both of these types of motions now, I just pulled it to the different types of acceleration that are happening with a change in speed. We can decide whether this is a positive or negative change in acceleration. So if we look at this top one right here, and we have the acceleration, or the speeds are getting bigger over time, we would say that this is a positive acceleration right here, if something is speeding up. And this one right here, our acceleration, or our velocity, said it again, our velocity is getting smaller, and so we would say that this is a negative acceleration for this object. So the big points from this video, the conceptual part of acceleration, is knowing that acceleration is a measure of the change in velocity during a period of time, and it can happen because of a change in speed and direction. So that is essentially the first half of this acceleration information, knowing how acceleration is measured, and then the next video we're going to be working on how to actually calculate this acceleration.